AVD auto-scaling sounds very simple, doesn't it? Right? You switch it on, you give it a schedule, maybe set a few limits, and then Azure just handles the rest, right? Hosts spin up when the users need them, scale down when they don't. That's the expectation most people actually have. But then reality kicks in, right? You still have too many hosts running overnight. You still get complaints in the morning that things feel slow. Or you look at your bill and think, this should be cheaper than it is. And that's the moment most people actually realise something important. Autoscaling isn't a magic feature, it's a system. And if you don't design it properly, it won't behave the way you expect. So what I want to do in this video is walk through how autoscaling actually works in AVD, why it often feels like it's not working, and what's really going on underneath, when users start interacting with the platform. Easiest way to misunderstand autoscaling is to think of it as a cost-saving feature. That's what most people focus on first, turning machines off when they're not needed. But that's not really its primary job. Autoscaling is trying to balance performance and cost at the same time, and these two things don't always line up nicely. Sometimes keeping performance stable means running more hosts when you'd like. Other times you can aggressively reduce capacity without anyone noticing. And the challenge is that autoscaling doesn't know that good and what good actually looks like, unless you actually define it properly. It doesn't understand your business, doesn't understand your users. It doesn't know when people will log on, how they behave during the day, or when your environment is actually under pressure. It just follows the rules. And that's where things usually start to break down. Let's talk about the most common real-world issue, because this is where autoscaling either proves itself or completely fails. Picture a typical environment, right? Users log in around 8:30 or 9 AM in the morning, right? Autoscaling is configured to start increasing capacity at 9 AM, which kind of feels logical, right? But that's when the working day actually begins. This is where the misunderstanding actually happens as well. Users don't arrive gradually in sort of neat, predictable waves. They arrive in bursts. Sometimes hundreds of users all try to log in within a short window. And at that exact moment, the environment is doing a lot of work kind of behind the scenes. Profiles are attaching, applications are launching, authentication's happening, and session hosts are trying to keep up. Now, imagine the hosts that are supposed to handle the load are only just starting. They're booting, they're registering, they're not ready yet. So, users hit that environment before capacity is actually available. From a user's perspective, it just feels slow, right? Logins take longer, session hosts feel inconsistent, and people assume something is broken. But technically, autoscaling is doing exactly what you told it to do. Just reacting too late. That's one of the biggest lessons with autoscaling. If your capacity arrives at the same time as your users, you're already behind. Once users are inside the environment, autoscaling decisions are heavily influenced by how many users you allow on each host. And this is where environments start to kind of drift into sort of inefficiency without people actually realizing it. Let's just say a host is configured to allow 16 sessions. Okay, because on paper, that looks like good utilization. You want to get as much value as possible out of each VM. That makes sense. But in reality, performance often starts to degrade before you even hit that number. What happens is quite subtle, right? And the host doesn't fail. CPU might not even look maxed out, but under the load, when multiple users are actually active at the same time, the system starts to feel slower. Applications take a little longer to respond, switching between tasks introduces slight delays. Nothing dramatic, but enough that users notice. At the same time, autoscale sees that the host hasn't reached its limit yet, so it delays spinning up a new capacity. Now you have this sort of mismatch, right? From Azure's perspective, there's still room, right? But from the user's perspective, it already feels slow. On the flip side, if you're too conservative and set low session limits, autoscale will bring up more hosts earlier than necessary. Performance will be great, but your costs will climb. So what looks like a simple configuration decision is actually shaping how autoscale behaves across the entire environment. Scaling up tends to be easier to understand, right? Users arrive, demand increases, and you add capacity. Scaling down is where things actually can get messy. Let's say it's late afternoon and users start logging off, right? You now have an opportunity to reduce hosts and save costs. But instead of users logging off cleanly from a small number of hosts, they're spread across the environment, right? Maybe every host still has a few active sessions. At that point, autoscale can't easily remove hosts because doing so would disrupt users. So instead of shutting down 10 hosts, maybe it shuts down 1 or 2. The rest stay running, lightly used, but still costing money. That's when people look at their environment and think, why are we still running this many machines when hardly anyone is online? It's not because autoscale actually failed, right? It's because the environment wasn't designed to consolidate sessions effectively before scaling down. This is where more advanced behavior like draining hosts becomes important, right? If you allow certain hosts to stop accepting new sessions and gradually empty out, you can then shut them down much more cleanly. Without that, scale down always feels inefficient. If any of this sounds familiar, especially the part where your environment looks quiet but your costs don't drop, that's not a coincidence. That's exactly what happens when autoscale is configured without really understanding how users behave. If you're working with AVD or designing these environments, this is the type of detail that actually makes a difference long term. So, if you're getting value from this, hit that subscribe button because I'm focusing on the real behavior of these platforms, not just sort of what the features say they do. What actually happens when real users hit them every day. This is probably the most important thing to understand now. Auto-scaling doesn't fix problems. It actually exposes them. If your host pools contain completely different types of workloads mixed together, autoscale has no clean signal to work from. Some users might consume very little resource, while others consume a lot. Autoscale sees sessions, but it doesn't understand how heavy each session is. So it makes decisions based on numbers, not behavior. That's when you start to see odd patterns, right? Some hosts feel overloaded earlier than expected. Others sit underutilized. New hosts spin up slightly too late or too early. And the instinct is to blame autoscale, but the real issue usually sits underneath it, right? It's the workload design, the session density assumptions, or the scaling logic not matching how the environment is actually used. Auto-scaling works best when the environment itself is predictable, when workloads are segmented properly, when user behavior is understood, and when the rules you've defined reflect reality. Without that, it's always going to feel slightly off. The simplest way to improve autoscaling is to stop thinking about it as a feature you just switch on. Think of it as a behavior you design, right? You're defining when the environment should be ready before users arrive. You're deciding how much pressure a host should handle before more capacity is added. You're controlling how aggressively the system should scale down as demand drops. And for that to work, you need to understand your environment properly. When do users actually log in? Not when you think they do, when they really do, right? How quickly does demand increase? Do users all arrive at once or over a certain time span? How sensitive is your workload to performance dips? Are all users roughly equal, or are some much heavier than others? Once you start thinking about those questions, autoscaling becomes much easier to get right. Because you're designing behavior, not configuring settings. If there's one thing to take away from this, it's this. Autoscaling in AVD is only as good as the assumptions behind it. It doesn't optimize your environment automatically. It follows the logic that you define, even if that logic doesn't reflect reality. That's why some environments feel perfectly tuned, while others feel inconsistent, even though they're using the same feature. The difference isn't the platform, it's the design. In the next video, I'm going to zoom out and talk about something much bigger. Why cloud migration itself often goes wrong, even when the technology is solid. Because once you understand that, everything else will start to connect. Everything I've spoken about over my last sort of 8, 9, 10 videos will start to make sense as well. But listen, I really appreciate everyone's support, as always. Make sure to like the video, drop me a comment around any sort of auto-scaling issues you've had and how you actually use auto-scaling in your production. And also, please make sure to hit subscribe. It's a new channel. I had my 60k subscriber channel before, started again, and I really appreciate everyone's support. And by subscribing, you are showing even more support. Thanks for watching and see you on the next one.